In the last video, we were introduced to trigonometric identities, and specifically we looked at the Pythagorean reciprocal and quotient identities. But there are some other categories to look at as well, so we're going to introduce some more identities in this video. First of all, sum and difference angle identities, and that's something like if you have the cosine or sine of an angle plus an angle. Now you would likely think, just by looking at this, that perhaps this was equivalent to the cosine of A plus the cosine of B. That would be a logical guess. So let's see if that's true or not. And of course we can always verify whether something's true or not, but just by taking a numerical example. So let's take an angle of 30 degrees for A and 45 degrees for B and substitute. So what we're saying is we want to know whether the cosine of 30 plus 45, which is the same thing as the cosine of 75, whether that is equal to, we're just going to put a question mark here because we don't know whether this is true or not, is that equal to the cosine of 30 degrees plus the cosine of 45 degrees? Alright, so we bring out our calculator in degree mode and let's type in each side independently. The cosine is 75 degrees, the approximation is that, and on the right side the cosine of 30 degrees plus the cosine of 45 degrees, is that the same? No, it's not. So as soon as we see that, we know that this statement above is not true in general. So the cosine of A plus B does not equal the cosine of A plus the cosine of B, which raises the question, well, what exactly does it equal? Well, as it turns out, it equals this. Now, to prove this is quite long and involved, and I'm not going to go into it in the video. You might do that in class. But let's just take my numerical example above and see if we can verify that below here, just to get a sense that it's true. So we'll use A and B as 30 and 45 again. So this would be the cosine of 75 still. And so according to this formula, the cosine of A plus B is the cosine of the first angle multiplied by the cosine of the second. So the cosine of 30 multiplied by the cosine of 45, subtract the sine of the first angle, 30, times the sine of the second angle, 45. So here we are, almost entered, and let's see what we get. We get a decimal the same as the cosine of 75. So we get the sense that this is true. Remember that you can't prove something to be true through a numerical example. It just gives you a sense as to whether it might be true or not. But I'm saying that this statement can be proven to be true, and we will accept it at that. So we have the sense numerically that this statement is true, and now there are actually statements for cosine A minus B, which you'll notice is similar, just that the sign here is opposite. Sine A plus B and A minus B. Notice a different pattern here. We have sine A cos B plus cos A sine B. You'll notice that when you're adding the angles here, the pattern in the identity on the right is a plus, which is different than the cosine one. Those match. And then there are two identities for tan A plus B and A minus B. Let's do a few examples to demonstrate how these identities might be helpful and how they work. We want to find the exact value using tangent 75. Now up to this point we've only been able to find exact values of angles involving 30 degrees, 45 degrees, 60 degrees. Those are angles in our special triangles. 75 degrees is not one of those angles, obviously. So what we're going to do here is we're going to take the 75 degrees and we're going to break it up in terms of adding and subtracting into two angles that either add or subtract to 75. Well, if I look at my list here, I could take 30 degrees plus 45 degrees. Now I'm going to bring my tangent A plus B identity in, copy it from the last page, and I'm going to substitute 30 degrees for A and 45 degrees for B into the right side. So this would be the tangent of 30 degrees plus the tangent of 45 degrees divided by 1 minus the tangent of 30 degrees times the tangent of 45 degrees. Based on our special triangles, if we have 30 degrees, we have 1, 2, and root 3 on our triangle. We know that the tangent of 30 degrees from that is 1 over root 3. And we know that the tangent of 45 degrees from the other triangle is 1. So I'm going to substitute these values in. And let's reduce this expression a little bit. I could multiply numerator and denominator of this by root 3 to get the complex fractions out of the way, the little mini fraction within the big fraction. If I multiply that through, I'm going to get 1 plus root 3 over root 3 minus 1, and that should do it. That should be the exact value of tangent 75 degrees. Let's check this out with the calculator. The tangent of 75 degrees is that, which means that this decimal, when I type it in, should be that value. Okay, just watch your brackets, and it is. Another thing we often do with identities is take expressions and reduce them to simpler ones. So we have 1 over cos x cos y minus sin x sin y. And with time, you'll hopefully recognize, as soon as you see a pattern like this, you'll recognize, hopefully, that that's one of the addition angle identities. So you can go and look it up. Cos, cos minus sin, sin, there it is right there. And so all of this, because of my identity, is equivalent to the cosine of the two angles x and y added together. And we can go one step further. We know that 1 divided by cos is secant. So this is the secant of our angle x plus y. Okay, here's another one. We have sine times cos minus cos times sine. And again, you'll hopefully recognize that as one of the addition angle identities. Let's go look at our list. Sine cos minus be this one right here. Right, we're looking for the minus and the pattern sine cos minus cos sine. So let's copy that over to our other page. So we're matching the pattern of the formula. Angle A is 2x, angle B is 8x. So this entire expression here reduces to the sine of 2x minus 8x. So therefore that's equivalent to the sine with an angle of negative 6x.